Hello, today I present the findings from our final Pyhs102 experiment, which focused on quantifying fundamental principle of electromagnetism, specifically the interaction of insulating material with capacitance. As we know, the capacitors are vital components for energy storage, and their capacity is inherently dependent on the dielectric material placed between the plates. The core aim of this experiment was clear: to precisely determine the relative permittivity epsilon r of common materials, which is cardboard, paper, and plastic, and air, by observing how they enhance the charge storage capability of a parallel plate capacitor. Our goal was to quantitatively rank these materials based on their effectiveness as dielectrics. Our experimental setup was highly controlled parallel plate capacitor. We ensured a fixed consistent plate separation distance of 3 mm and no overlap area. Crucially, our methodology focused on eliminating common producible error. Like the errors can be because of the cardboard and the inside of the cardboard. There's an air inside the cardboard, and it could occur some errors because of it. So rather than relying on traditional RC time constant method, which is susceptible to human reaction time and oscilloscope reading errors, we opted for direct measurement using a capacitance meter in a multimeter. The procedure involved 4 primary steps. First, we establish our baseline C air. With only air between the plates, we use the capacitance meter to record reference value, which was found to be 71 pF. Next, we tested the electric materials individually for each sample cardboard, paper, and plastic. We ensured it was placed securely to fill the gap. We then used the capacitance meter to directly measure the new capacitance C material. Finally, we calculated relative permittivity epsilon r for each material using the straightforward ratio epsilon r equals to C material divided by C air. So in constant, cardboard provided the smallest enhancement, measuring 95 pF, yielding an epsilon r of approximately 1.43. Paper, placed centrally with an epsilon r of approximately 1.73. Our findings demonstrate a ranking of the electric capability. Plastic provides the best performance, followed by paper, with cardboard trailing. This ranking directly correlates with the density and purity of the materials, verifying the less porous materials are generally better dielectrics. In conclusion, despite these minor experimental limitations, the experiment successfully achieved its aim, providing clear quantitative evidence that different insulating materials' predictability and significantly modulate the charge storage capacity of a parallel plate capacitor, with plastic proving to the most effective dielectric tested. And this is my Pyhs102 experiment. That's all.